Hello, everyone. My name is Taz, and welcome to this deep dive session on AWS Analytics. Today, we will be demonstrating user experience on observability, where you can understand the behavior of applications and infrastructure. We'll be talking about ETL, where you can write minimal to no code to do your extract, transform, and load, and then how to effectively govern your data. Amazon Open Search Service. It has built-in observability tooling such as trace and event analytics, as well as log analytics. Next, we will demonstrate AWS Glue, a fully serverless data integration service that lets you discover, prepare, and integrate all of your data. We'll start with Glue Studio for visual, low-code development experience, and then move on to AWS Glue Data Brew for a no-code experience. And then finally, AWS Lake Formation for data governance. Lake Formation gives you a single place to enforce access controls that operate at the table and column level for all the users and services that access your data. With that, we thank you for your time, and let me pass you over to my colleagues.
Good afternoon, everyone. My name is Ragora Sodabattina. I'm an enterprise solution architect based out of Boston. Today, we are going to work on observability and operational analytics workshop by using Amazon Open Source Service. Before we get into the workshop, right, let us talk about what is Amazon Open Source Service, and also we will spend a couple of minutes on workshop architecture, and then we will jump onto the AWS Management Console, where I will show you the demo of building operational analytics by using Amazon OpenSearch. So let's talk about what is OpenSearch service. OpenSearch service is basically it's a managed services out of open source OpenSearch, and it comes with observability tools where you can do the trace analytics, event analytics, and log analytics. By combining all these three mains like trace analytics, event analytics, and log analytics, you can build a operational analytics pipeline to provide better customer experiences to your customers, because you really wanted to know what is happening to your applications and infrastructure. And with this, you can also basically build some business metrics based on your business requirement, and then also you can do the proactive alerting based on what you see with your operational data. And it integrates with Amazon Kinesis Data Firehouse, Amazon MSK, Amazon CloudWatch Logs, and other tooling. For today's workshop, we are going to use Amazon Kinesis Data Firehouse. So this workshop is based on workshop based on the lab guide. This lab guide is available over public internet, and if you are you can do this workshop by your own in your AWS account by following above guide, or if you are working with any AWS solution architect, they can get you Event Engine with a temporary AWS account, and then you can also follow the lab guide to complete this workshop. So let's talk about workshop, what we are going to do. So basically, we are going to collect the Apache server web logs from the application, and then we are going to use Kinesis generator. It's kind of a tool to generate some Apache web server logs. And then we are going to use Kinesis data firehouse to deliver the data into Amazon OpenSearch service. And then we will create a couple of dashboards by using Amazon OpenSearch dashboard to see your Apache server logs. That is architecture. So let's talk about this is the Kinesis KDZ template. This is just to simulate Apache web logs, where you can basically, instead of getting a real data, we just wanted to simulate some dummy data for this workshop. And lab architecture, if you are doing it on your own account, it comes with the CloudFormation template. When you deploy the CloudFormation template, it comes with this architecture where you will have like a VPC with 2 public subnet and 2 private subnet, and then you get like Kinesis data file host. Kinesis data generate comes with that, but we are going to create Kinesis data file host as well as Amazon OpenSearch service. So, I mean, these are the resources to get started. So now I'll go back to the management console. If you look at this is the workshop, dive into Amazon OpenSearch workshop. This is the workshop we are going to do. The first step is, as I discussed, right? There are 2 ways you can do this workshop. One is event engine. If you are working with AWS Solution Architect, they can get you the temporary AWS credentials, and then you can follow these instructions. But you can also do the lab on your own by downloading this CloudFormation template into your AWS account. This is the instructions. So the first step is we have to create a domain. All right. So I'll go to the Amazon OpenSearch dashboard. First, we have to create like a domain name. You can keep as a workshop. Let's call it as a operational analytics workshop. And then for this purpose, right, we can use the development and testing, and always try to choose the latest version, and then keep this auto tune enabled. And we always recommend at least launch your Amazon OpenSearch cluster into 2 availability zone minimum, because we wanted to make sure that your cluster is up and running. So when you select 2, then you will have like 2 nodes. And then your storage is going to be a EBS. For now, we'll leave it to default. And again, you can have your dedicated master nodes. For this workshop, we are not going to do. Master nodes is nothing but it's kind of a engine who manages everything, right? Data node is nothing but where you store your application data. It's data stored in the form of indexes. And the network, right? Because this is kind of your source data where you are getting from your applications and infrastructure, we always recommend you to launch Amazon OpenSearch in a VPC. So here, this is the VPC which is provisioned along with your AWS CloudFormation template, and select private subnet 1, and then another one, private subnet 2. And it also comes with a security group. You can just select the security group workshop. And then here, right, we are going to create a master user ID because we wanted to make sure that we provide fine-grained access control. How we can, you can choose some user ID password. For this example, I'm using admin as a user and then some password. Make sure that you remember password because you are going to use this password to log in into OpenSearch dashboard. And here it comes with a SAML authentication where you can use your external identity providers like Okta, Auth0, Pinganity as well, or you can use Cognito. For this workshop, we'll just use this. We'll just use by using admin and user ID and password for now. And then here, always make sure that you do the fine-grained access control. And for now, you can just leave it everything default. So this is how you create your OpenSearch. And it says like has to be 3 or more characters. Okay. I'll put like analytics. Okay, so I'm not going to create because of time, because we have only 20 minutes. I already created Amazon OpenSearch cluster. If you see, right, this is up and running. Now, if you go back, right, once we create a domain, as you know, right, we created this domain in your VPC. In order to connect your VPC, it comes with reverse proxy, right? That is where you have to run few commands to run the reverse proxy, right? So it comes with, if you see here, run shell command. If you just click on it, it will take you to the AWS System Manager run command where you can basically execute some of the command. If you look at the lab here, what we are going to do, basically you copy config update, right? And then put it here, and then just enter your Amazon OpenSearch cluster ARN, right? So this is the domain endpoint. You can just copy this. When you click on this, right, basically you are going to choose the instances, and this is the instance it already created along with your cloud formation template. And you can just disable it, and then you can run it. It will run it. Because I already ran this, I'm not going to run it here. If you look at it, this is the reverse proxy created within your VPC to access OpenSearch dashboard. So if I click on here, it will take me to Amazon OpenSearch dashboards. And this is where you can see the OpenSearch dashboard. Now the next step is, if you look at here, we are not going to talk about search and analytics. That is another use case where you can use Amazon OpenSearch for search workloads as well. But we will focus more on data pipeline, right, where you are bringing your application logs into OpenSearch. So the first thing is you have to create a Firehose. Here you have to put a source, right? Here source is a direct put. Direct put means like you are directly ingesting data from your application logs into OpenSearch, right? That's the reason we are doing it as a direct put. And then here destination. Amazon Kinesis Data Firehose can deliver data into multiple storages like Amazon OpenSearch, Redshift, S3, Datadog, Dynatrace, and all. For this example, we are going to create Amazon OpenSearch service. And then we have to put a name here, right? Because we are doing like a weblogs. We can put a name as weblogs1. And here, right, you have to browse and select your Amazon OpenSearch cluster. I already created OpenSearch workshop. That is what I'm going to choose it. You can put the name of the index, because Amazon OpenSearch is like a database. The only difference is the data is stored in the form of indexes, unlike table, rows, and columns. So we can call as index as weblogs. And then for index rotation, you can do the rotation here every hour and all. For now, just leave it. And then you automatically it's selected here. You can leave all this for now. You can choose like errors, right? If some errors you wanted to capture, those errors can be logged into the S3 bucket. Under advanced setting and the buffer, right, you can change it to this 1 minute, because we don't want to send 5 minutes. And then buffer interval, you can reduce to 60 seconds. You can keep rest of the settings here. I mean, you can do the encryption of your data. You can click on the create delivery stream. That is where it created. For the purpose of time, right, I already created Kinesis data stream here. If you look at here, I have weblogs delivery stream. Here is the delivery stream. The thing is, we already created now, so we need to provide access to your Amazon OpenSearch cluster, right? To pull the data from your application logs into Amazon OpenSearch cluster, right? For that, what we have to do, if you look at here, we have to set up a permissions, right? Where we have to go to the Kinesis here, and under configurations, you see there is an IAM role. You just click on this. We have to collect this role ARN. Yeah, this is the ARN. You can just collect it, and then we go to Amazon OpenSearch. Here, you go to, if you look at here, we go here, and then go to the basically security section of OpenSearch here. Here is the security. And then here we need to map the users, right? If you look at here, what we need to do, basically look for a role, all access role. That is where we created admin user ID, and that is where we are going to map the user, right? So role here, look for all access. So this is the admin user ID, but we look for all access. I already did. That's why it is not coming. So what we have to do here, you have to copy this role, and then you map it. And then what we are going to do, right? We are going to send some application data. We are going to simulate the data such that we are going to send some Apache server logs data. So for this, right, as I mentioned, right, we are going to use this Kinesis data generator. It's kind of a tool which will generate Apache web server logs, and then it will send these log files into Amazon OpenSearch cluster through Kinesis Firehose. So for this, what we need to do, right? Let's go here, and then you just copy this user ID password. This Kinesis data Firehose comes with your CloudFormation template. If you go to the CloudFormation template and come back and look at the outputs, here basically you can take this URL. That is what it is. Here you have to put this user ID. This user ID password is in the lab guide. You can just take the password, put the password here, and then sign in. Because if you look at, right, we are in US East 1. And then automatically we created a Kinesis Firehose called Weblogs. It automatically populated here. And then here we are going to copy the code from the workshop here. So this is a simple JSON code just to generate some of the Apache web server logs. So what you do, you take this and then come here and then paste it. And then once it is done, right, let's send some data, right? We are going to send the data. See, it is keep on sending. Let this run the data. It is going to send the data for some time. And then now come back to the OpenSearch dashboard. If you look at here, now we are going to see the data, right? How you have to create an index, right? That is where you go to the stack management and then create. So you come back here, stack management, and then index pattern, right? Here I already created one thing called Weblogs. I mean, you can click on create, put a name here. That's how you create it. Now the next setup is like once you are done, then you should be able to see the logs. That is what we are going to see here, right? So you come back here and then click on discover, where you can see, right? So this is the logs. You can see, right? This is the count and data is coming, and this is last 15 minutes. You can also change to maybe you can change it to today, right? And then see, I sent some data around the morning, and then now data is you can see like each request what is coming here. All right. Other thing is the important thing is like, right, based on this dashboard, right, you can see you can also create basically a detector. All right. Your detector could be like you wanted to track 202 error, right? For example, non 200 errors, right? That is where you can create a detector. All right. If you go to dashboard here, for example, here anomaly detection here, you can create a detector here, right? You can create, you put a name here and then put a data source as weblogs, and then put the timestamp thing, and then go to the next step. You just follow the lab guide here. Basically here, if you look at here, right, you create a detector. You wanted to track like all non 200 errors. This is the non 200 errors. Your source is weblogs index, which we already created. And then you wanted to track like status, which is not 200. And then every minute you wanted to track it, right? Once you're done, then you just configure the model. You wanted to get a count of the status, right, which is not HTTP status not equal to 200, right? So I already created here. We will go and look at the results here, right? Here is the detectors. I created one detector here, and you see that here I got here it is greater than 1, And then you can also basically, this is a live data, all right? If you wanted to change it, you can also change here. Today you can change it. You can also do the historical analysis because it's happened. You don't have the much data here. Okay, this is how you can build operational analytics on AWS by using Amazon OpenSearch. And here you have a lot of other things. I mean, once you have the data, you can see what is the anomaly grade, and also there is a lot of dashboard which you can create it. The purpose of time, I'm not doing that. If you wanted to learn more about Amazon OpenSearch, this lab is available over internet. As I said, you can do it in your own AWS account, or you can work with AWS Solution Architect, and they can get you the temporary AWS account with Event Engine so that you can perform this lab where you can learn both operational analytics as well as search workloads as well. Thank you so much for your time. If you want to learn more about Amazon OpenSearch, please reach out to me. Thank you. And here are some of the resources where you can look at AWS documentation to learn more about Amazon OpenSearch. If you wanted to learn more about the roadmap, our roadmap is available in GitHub. And this is the developer guide to learn more about Amazon OpenSearch documentation. And also, we have social media networks. You can follow us in Twitter or LinkedIn so that you can learn more about what is coming with Amazon OpenSearch. Thank you.
Hello, everyone. Welcome to the Lake Formation demo. I am Aarti Srinivasan, and I'm a senior big data architect with the AWS Lake Formation service team. Here in this demo, I'm going to show you how table permissions, how database and table permissions are managed by Lake Formation. The underlying data is sitting on S3, and the data buckets with the data sets are registered to Lake Formation. And I'll be showing you two ways in which we can share these database and table access to individual IAM users. One is using the named resource method, and the second one is using the LF tags based permissions. In the named resource method, I'm going to show you how to provide a restricted column access on a table, as well as I will show you how to create and use data filters on one of those tables and share it with different users. I'm going to show you these permissions, how these permissions are granted and how the tables are accessed using Amazon Athena. And second, I'm going to show you also using how Redshift Spectrum works. It's a simple arrangement here. For the demo, I have created multiple users. One is the data lake admin. The admin is the IAM user you authorize as from login as a account admin, and you authorize or create this data lake admin user as an IAM user. Then you authorize or make this data lake as the data lake admin user as the admin for your data lake formation settings. And I have also created two IAM users, Tom and Jerry. I call them lake formation Tom and lake formation Jerry. I have also created a spectrum role. This my spectrum role is an IAM role that I have created as per all these Tom, Jerry, and my spectrum IAM roles and IAM users. I have created as per the lake formation documentation and Redshift Spectrum documentation. I have created policies and attached to these roles and users. My spectrum role, I'll use it from, I have attached it to my Redshift cluster, and I will be using it from my Redshift Spectrum and run few queries. And I have created few databases, database 1, database 2, and Amazon Reviews database. And I also created another hoodie_db database in my lake formation or glue catalog. And all these databases have underlying data sets in S3. And that particular S3 bucket is the one that I have registered with lake formation. And now on the Amazon Reviews database, and there is only one table inside that database, Amazon Reviews _Parquet. And I have created a restricted columns permission on the table for the lake formation Tom user. and I have created a data filter on the table and given access to Jerry based on that data filter to that table. So they will both have restricted access to that table contents, and we will see how it flows. And similarly, I have created LF tags called the classification and user role. I have created values restricted 1, restricted 2, user role equals architect and DevOps. And I have tagged the database 1 and 2 as shown in the picture here. And I have given access to Tom and Jerry, access based on the LF tags, user role equals architect for Tom, and classification equals restricted 2 for Jerry. Now, based on these tags permission policies, Tom will get access to database 1 and Jerry will get access to database 2. And we are going to see all these in the lake formation console, respectively, with those users. First, let me show you how I have created these roles and stuff. I have logged in as Arts. This is the IAM administrator role with all permissions to my account. This is not the same as lake formation admin role. I need to log in as the IAM administrator role to show you the IAM permissions and my S3 bucket policies and stuff like that. So here I am showing you, let me first show you the user groups here. So under the user groups, there are developer groups I have created here. And lake formation Tom and Jerry are added to this user groups. These users will have corresponding permissions. As you can see here, there is no direct S3 access. And writing Athena results to S3 policy, it has S3 access, but all these buckets are not registered with the lake formation. So here I will show you this Arts lake formation bucket. This is the only bucket which has all my data sets. And this is the only bucket I have registered with lake formation. So any non-lake formation bucket, I have to separately give access to those IAM users and roles. Okay, that's what I have given here for writing Athena results to S3. As I show you here, none of these buckets are Arts-lake formation. You can see that there is an IAM pass role here, no S3 permissions directly. And the Glue access also, I have given permissions to work on the Glue data catalog, and there are no direct S3 permissions. And you will see also here that my Arts-lake formation bucket, the bucket policy is empty. Got it? So lake formation, once I register this bucket as to be managed fully by lake formation, there are no S3 policies, bucket policies required at all. So this is one aspect where lake formation simplifies managing access to S3 structured data in S3, which is cataloged in Glue catalog. Okay, I will also show you the MySpectrum IAM role, MySpectrum role IAM role. This is the role I have attached to my Redshift cluster. Again, you will see here that there is no direct S3 access. It's only Glue star and lake formation get data access API call. There is no other S3 direct permissions to my Arts-lake formation bucket. So that's pretty much the actual setup of the IAM roles and stuff. So now let me log in as Data Lake admin. So the Data Lake admin is the administrative role that is registered here. Administrative roles and task. I have registered Data Lake admin as the main IAM user to be completely managing my lake formation settings and my data lake. And in the data lake locations, I'll show you that I have registered my Arts-lake formation bucket, which has or hosts all my data sets, which I have cataloged in my Glue data catalog in US East 1 region. Okay, so let's see what the other consoles in the lake formation I have here. I've shown you the Arts-lake formation bucket that is registered. I'll show you some of the databases here. In the databases, I have database 1, 2, Hoodie database, and I'm also using Amazon _ reviews database. Okay, in the Amazon reviews database, I have only one table here, and I have created a data filter on this particular table. And this is called Amazon review _ books. Let's see what this is. I have excluded column access based on this data filter. I have defined it as product category column equal to books, and exclude all these particular columns from that table. So this is what the data filter will filter access on this particular table, and it will show you only the relevant columns for the user who is given access to this table using this data filter. Okay, so that's one thing. Let me show you what's inside that. So these are the databases I have showed in my account. And database one, for you, I'm showing you that I have created LF tags, and I have created classification and tagged database one with a value restricted one, and tagged it using user role equals architect. Remember this, okay, as shown in the picture. Database 2, I have again created an attached tags user role DevOps and classification restricted to. So these are the two important key databases. And now for the lake formation Tom IAM user, what have I given permissions to? So in the data lake permissions, when you click on the data lake permissions tab, you will click grant, and it will take you to a window where you can select. Let's do it once. Okay. It will show you, you can choose which IAM role principal you want to give access to. You can also choose SAML users and groups. You can on QuickSight ARNs too. And you can also choose any additional external AWS account. It doesn't have to be within the same AWS organization. It can be any external AWS account. So you have multiple choices here to choose whom you want to give permissions to. And then, as I described before, there are two methods which you can choose to grant permissions to: named catalog resource method, and another is using the LF tags. And you can go ahead and once you enter the value for you choose the database, tables, and data filters, you can choose whatever permissions at the database level. And then once you choose the table, it will show you the table level permissions and etc. And you will do a simple grant, click the button, and say the permissions for those. This is how you define lake formation grant policies or access permissions for any IAM principals or users or external AWS accounts. Now let's get back to the permissions, data lake permissions, and review the permissions that I have filtered it based on lake formation Tom. And I want to see what permissions I have granted to the principal lake formation Tom. Lake formation Tom is an IAM user, and you can see that I have given permission on the Amazon reviews database and this particular table inside the database, only restricted column access. And I have chosen include only certain of these columns. I have given access to only 6 columns. Okay. And it will be select permission on these 6 columns on this table. So this is a restricted column access method. And secondly, I have given access to a certain LF tag expression. I have given permission for this Tom user on both classification and user role to describe and associate permissions. But on a tag expression, I have given permission on the database and table access only to user role equals architect tag expression. Okay, this is for lake formation Tom user. And similarly, what I have done for Jerry. For Jerry user, I have given access to the Amazon reviews database and the Parquet table using a certain data cell filter, which I showed you before. So using this data cell filter alone, this user Jerry can access this table. He can describe and select permissions on this table using this data filter. So whatever the data cell filter outputs, that's what the Jerry user will see. And again, in the using a tag expression, LF tag expression, I have given access to tags classification equals restricted to. Jerry can access the database and table which has been tagged with the value classification equal to restricted to. And let's also see what I have given permissions to here in the my spectrum role. So let's get back to the data lake permissions, and I will filter based on the principal my spectrum role. Let's see what permissions the my spectrum IAM role has permissions to. So I have given permissions only to the hoodie underscore DB database, all table and all column permissions inside this hoodie DB database. You can the my spectrum role can select, describe, insert into all the database tables in this particular hoodie underscore DB. Okay, so this is the view from the data lake admin. Data lake admin is required to set up all permissions in the account. Now let's log in as for example, lake formation Tom user, and let's see what he has access to and how he will go about navigating the database and tables he has access to. For example, I have chosen Athena. So in Athena, he should be able to see Amazon reviews table and using the column level permissions given to him defined on the Amazon reviews table database. And similarly, Tom will get access to database one. This is by definition of the LF tag expression. Okay, so let's do a simple query here. So Amazon reviews, again, he has only restricted column access, though this table has multiple columns. He should be able to see only 6 columns. That's all the access he has been given to. So let's run this query, preview table, and see. Yeah, so he has access to the 6 columns that has been assigned to him in the lake formation permissions definition. Similarly, he has access to all the tables inside database one. You see here all the 4 tables inside the database one. This is not through direct named resource method. This is through LF tag expression method, and he can run a query on any of these tables. And let's do a simple preview. There you go. He has access to all the columns in all the tables under database one as per the LF tag expression. And let me, so that is what the 2 sets of database that he will have access to here. Okay. And let's also quickly see how the Redshift permissions work. I will log into, this is my Redshift cluster, which is running, and I'm going to use the query editor v2. Here you'll notice that I am logging in only, logging to my query editor and my Redshift cluster as Lake Formation Tom user. But here, I have created the external schema. This is Redshift Spectrum command. This is how you create the command, Redshift Spectrum. And Redshift Spectrum schema, you are creating Spectrum underscore Hoodie DB and mapping it to the Hoodie underscore DB database, which is already present inside my Glue data catalog. Glue catalog is pointed to using this keywords data catalog. Okay, now for this Spectrum configuration, I am using the IAM role, my Spectrum role. And I have already, in my Redshift cluster, I have attached this role. I have created and shown you the permissions to this role. It doesn't have direct S3 access, but as you see here, I can refresh my Redshift cluster configurations. And dev is the default database. And I have created Spectrum Hoodie DB. I will click here to refresh, and it will populate all the tables that this My Spectrum role has access to. As you see here, there is one table. There's only one table present in my Spectrum Hoodie DB, and that is the New York Yellow Taxi driver datasets. Okay, so I have run this My Spectrum select query here already once, but we'll run it again. You'll see the first few columns are based on Hoodie dataset type format table. So the first few columns are underscore Hoodie created by or generated by Hoodie data format. The rest of the columns starting from vendor ID or the actual or the original dataset in S3. You see, so it's as simple as that. Once you set up your IAM roles, grant permissions to these IAM roles using lake formation permissions alone. You do not need to manage your S3 bucket policy, or you do not have to go and constantly edit your IAM user or IAM role policies. All you need to do is manage the permissions through lake formation, and your access to those S3 datasets work like a charm. And for example, I have also went ahead and created another Spectrum underscore database schema in my Redshift Spectrum, pointing to the same Glue catalog, but this time I am pointing to database one. But as you have seen before, I have not given access to this database one any permissions to my Spectrum role. So even though I created this, it will not work. As you see here, I'll refresh the Spectrum's database one. You will not be able to see any. The tables here is 0. So there are no table access given to the My Spectrum role. You saw that here in the lake formation, Tom has access to database one, but here it is the My Spectrum IAM role, and it doesn't have access to database one. It doesn't have access, no table access, 0 tables. So that's about it for lake formation Tom. Now let's see how lake formation Jerry will see access or manage access to his database and tables that he has access permissions from lake formation. So I have logged in here as the Jerry user. Again, in Athena, he should be able to see the database too using the tag expression, LF tag expression, which is restricted to, classification equal to restricted to. And he will have access to all tables inside this database. Just to do a quick preview of any of the tables, all columns are accessible to Jerry in this, all the tables from database 2. And let's see how he has access to Amazon Reviews database. You remember we created a data filter and gave access to Jerry only through that data filter. So Amazon Reviews Parquet table, Jerry will have restricted access and he will have access only to product category equal to books. So let's do a quick preview of this table and see if he is able to see anything else. So now this, with this whole idea is that Tom, Jerry, you can bring in any additional IAM users or IAM roles for which your applications can use. You can completely manage permissions for those database and tables to different users and applications in your account or cross account only through lake formation. Here you will see he has access to only those 6 columns and all of them product category equal to books, nothing else. If I run the same query saying where product category equal to camera or something, it should bring 0 results. Where product category equal to camera. Let's see if Jerry can see a lot more than what he's been given access to. Boop, no results. There you go. So this is how, and also in the lake formation console, you will see access to Jerry is only the Amazon reviews and the database to databases. So that's a quick demo of how lake formation can be used to grant access, restrict access to database and tables in the Glue catalog, and whose underlying data is sitting on S3 and registered with lake formation. I hope you enjoyed this demo of lake formation, and hope you all can get started and test out permissions management through lake formation. Please reach out to me for any additional doubts. Thank you very much.
Hello, everyone. This is Ramkumar Notat. I'm a senior solutions architect at AWS, focusing on analytics services. Today, the topic of this demo is AWS Glue, a data integration service for every user. AWS Glue is a serverless data integration tool which can handle complex workloads. It's a serverless tool, so there is no infrastructure to maintain. And the best part of it is, it's a tool which provides a data integration capability for every user, whether it's a visual ETL development for data engineers, notebook style development for data scientists, or a no code development for data analysts. You have various interfaces which can help you to do the data integration based on the persona that you have. And it's cost effective and it can handle complex workloads, and there is no code lock-in because it's all open source code which you can uh, edit, or you can take and port that over to any other platform that you would like. Now let's take a look at some of the interfaces, the various personas it handles. The first one is Glue Studio, where if you are a data engineer who prefer visual low code development experience, that's where you'll be using Glue Studio, where you can drag and drop various nodes and connect them together and join various data sets and databases and then move forward with it. Whereas if you are someone who prefer code-based experience, that's when you will be using Glue notebooks or interactive sessions, um, where you can directly type in the code in a notebook environment and interact with the data. And Glue Data Brew is the tool for a no-code experience for data analysts, where you can point and click various options, around 350 plus transformations that are out there, which you can point and click and make all the data prep activities, do all the data prep activities, and each one of those steps that you are doing gets recorded as a recipe. let's get right into the demo. Here I'm on AWS console. So the first thing that we are going to do, look at out of the three personas that we discussed, we'll be looking at two of them in this demo. One is Glue Studio and the other one is Glue Data Brew. So let's start with Glue Studio. For that, I will go into AWS Glue service. Once you land into AWS Glue service, you will see two different sections here. One is data catalog and the other one is data integration and ETL. Now, the top section here is the place where you store all your metadata. So here the databases and the tables that are listed here is purely for the metadata. It's not the databases that you store the actual data. This is purely for the metadata that you are storing. And the tables are the tables that you have cataloged in those metadata databases that you have. Now, once you catalog the data, then you can use Glue Studio to access that easily and then process the data. And there are wide variety of ways in which you can connect to various sources. And let's take a look at that. I will open up Glue Studio. And here in the burger menu, if you click on that, let's click jobs. And we will start with a blank canvas. Let's go ahead and click create. So this is giving you a blank canvas. Now, in any data transformation, you will have three major sections, right? For example, you will have a source from where we are pulling the data, and then you have a lot of transformations that you want to do, and then you have a target where you want to push the data to. So let's take a look at those. So in the source, there are a wide variety of options here. I can select AWS Data Catalog as one of the sources, or if I have data that is sitting on S3 and I want to directly access that, yes, that's fine too. We can do that as well. And if you have streaming data that is coming from Kinesis or Kafka, you can tap onto that directly, or other JDBC sources. So you have a wide variety of options that you can choose from. So in this demo, I'm going to select something that I have already cataloged in AWS Glue Data Catalog. So I will select that. The moment I select that node, you will have the options that are coming here to pick the database. Again, just to be clear, here the database means the metadata database that we saw in the Glue Data Catalog section. So I will select the ticket data database, and these are the various tables that are there. And I will go ahead and select MLB data for our demo. Now I've selected the node. If I look at the output schema, you can see that the schema is populated here. So this is pulled from the data catalog, because in data catalog, we have already cataloged the structure of the data set that we are using. So that's where it is getting this data from. Now, on top of this one, right here, you can see this untitled job. So let's go ahead and update the job name. For example, let's say demo job. And so we have the source now. Let's go ahead and add a transform. For example, let's go ahead and add apply mapping. Let's keep it simple. And I will go ahead and drop a few fields in the apply mapping. So let me go ahead and drop some of these fields. And then what I want to do next is apply a filter. Let's do some transformation. So I can look for filter, or if I want to run a SQL, I can type in SQL and select a SQL node. So for our use case, we will just go with a filter. So there are a wide variety of transformations here as well. So you can pick and choose any of these things, including a custom transform, where if you want to go ahead and code and put in some custom code, you have an option for that as well. So we added a filter, and let's go ahead and add a condition. So the condition that I want to go with is where MLB team matches ATL. Now, a cool feature is data preview. So because let's go ahead and start a data preview session. So here I'm selecting a role which has access to the various assets that we are dealing with. So I confirm that. Now, if you are an ETL developer, typically what you do is you make a change, test the job, figure out what is going on, and validate whether whatever you have coded is correct. So it's an iterative process, right? So there is a lot of time spent in that unit testing. Whereas the data preview helps you to validate that then and there so that you don't have to run multiple cycles to do that. That's advantage of data preview. So it may take a few seconds, but while it is doing that, let's go and take a look at the job details tab. So this is where you have the various configurations that you can add. So you can see that it's the role that we selected and the type of job that we are running. It's a Spark, and the version of Glue and Spark or Python that we are using, and what type of worker, whether it's G1X or G2X, what worker that we are using. And this is where you can, if you select this option, where automatically scale the number of workers, Glue will automatically scale up or down based on the needs that you have, your job is having, right? And job bookmark is a feature where you can, if you enable that, it will monitor, it will keep track of the various files that it processed from the previous run and make sure that if you execute the job again, it will only pick up the new files that arrived. So that's the job bookmark feature. So those are the various options that you can choose in job details tab. Let's go back to the visual and take a look at the data preview. So now the data preview is out there. So here you can see that MLB team, there are different teams right here. And what we put in our filter criteria is MLB team as ATL. Now let's take a look at the filter transform and go to data preview, and let's select MLB team just to make sure we are seeing the right data. Looks like our filter is working fine. So we are able to validate that only ATL, MLB team ATL data is coming after this point. So like this, you can as a next step, you can do more transformations. You can bring in other sources, or if you want to go ahead and land this data into a target, let's select Amazon S3 as a target, for example. And there are there are options for various data formats, and I will go with Parquet and compression type as snappy, and we'll select a S3 bucket. So I will select this one, select this, and let's put, so we are ready to save all the changes, and once this is done, we are ready to go ahead and execute our job. Now, one cool thing is if you click on script, whatever changes that we did visually, it generated the code for that, where you can take the script, download the script or edit the script and make do other changes and reuse that for any other jobs that you want to execute. So that's how Glue Studio works. Now let's switch gears and go into Glue Data Brew. So I will go back to the console. Let's select Glue Data Brew, or you can type in Data Brew here as well to get to Glue Data Brew. So once you're into Glue Data Brew, there are multiple tabs that you will see here. The first one is data sets, where you are registering the various data sets that you want to work with. So it could be a data set. Let's click on connect a new data set so that we get to know the options that are available, right? So if you click on that, you can see that you can bring in the data directly from S3 or Redshift or other JDBC sources, or you can very well bring in the data that is already cataloged in data catalog. For example, if you click on data catalog on S3 tables, the various metadata databases are listed here, and you can select those databases and the respective tables and register that data set here. So once the data set is created, it's nothing but a pointer, right? So you are just naming the data set and providing a pointer where it resides. So in this case here, you can see that this is using a database connection and it's a database table, whereas this particular, the second one, sales data set, is a CSV file which is sitting on S3. So there are various options using which you can connect to a new data set. And once a data set, once you have connected to a data set, the next activity is to create a project. So if you click on create a project, and let's say test project, here it will list all the various data sets that you have, and you can choose any of those data sets. For example, let's select census adult, and you can provide the permissions that are needed, basically the IAM role which has access to these assets. And here, if you look at, there is something called sampling, and by default there are some options out there, and you have an option to choose the sampling that data brew can do. So basically, project is nothing but a workspace where you are sampling some data, bringing that into a workspace where you can see the data and point and click and do the data preps. So it's basically a workspace. So how do you want to do that sampling is what you are providing here. So there are some default options, but you can very well select and say that I want, instead of first 10 rows, I want last 10 rows, random rows, and how many number of rows that you want to pick. All of that you can do. And then we can go and create a project. Now the project creation typically takes 1 to 2 minutes. So just to save that 1 to 2 minutes, what I've done is I've created the exact same data set, basically a project with the same data set. So let's go in there. So the moment you create a project, what happens is you will get something like this. So as a data analyst, anytime when you look at the various uh, metrics or various features in a data set, the things that you want to know is, one, what are the columns, what are the data types, how is the data looking, is it uh, does my data has a lot of missing values, invalid values. These are the things that you typically look at, right? And the beauty of AWS Glue Data Brew is the moment the project is loaded, all that information is provided to you based on the sampling that is done. So if you click on the schema, you can see a lot of information about that. For example, you can see that for work class column, there is 4% of data that is missing. Similarly, for occupation, again, 4% of data is missing. And you can also see a value distribution and the box plots on these how these values are distributed. And you can run a profile job on the specific data set, and depending on uh, you have an option whether you want to run it on the whole data set or x number of rows. You can choose that, and then it will give you a good graph on the correlation of various fields, the correlation among various fields within that data set. For example, if you look at this one, there are some negative correlations between the various fields that are present in this data set. It also provides you um, much more detailed metrics around the various fields that you have. For example, you have for each one of these fields, you can figure out what is a value distribution, what is a z-score distribution, and various metrics around each one, or data quality metrics around each one of these fields. So let's go back and let's go to the grid and see how easy it is to do some data preps, right? So we saw that in the work class column, there are some null values, right? And there are some missing values. So how do you want to handle that? So all what you need to do is you can select the column and click on remove or fill missing values. When you click on that, you have several options: either remove those rows which has a missing value in it, or fill with a custom value, empty, null. So there are a bunch of options, and let's go with remove missing value and apply. So the moment that is applied, you will see that that came into effect here, and that step is recorded as well. Now, each one of these tabs, you can do filters, you can do a lot of formatting, cleanup, or you can do joins or groups. And there are a whole lot of functions that are available. For example, math functions, aggregate functions, text functions. So each one of these is just a point and click. And any of these steps that you are doing, it just get added here. So let's do one more transformation. Let's click on the final weight column, and let's try to identify outliers. Now, I don't want to remove outliers, but I want to flag them. So let's go ahead and flag outliers. And it gives you option on what is the logic that you want to use for outlier detection. So we will go with z-score outlier with the 3 standard deviation threshold. And it is asking what is the value that it has to use, whether it's true or false, 0, 1, and things like that. So we'll go with true, false, and the column name, destination column name. Let's go ahead and apply. And the moment it is applied, you will see that there's a new column that gets added, and it will have all these various um, flags created. And you can see that there are 3 records, which is true, which is an outlier. So if you click on that, you can see that, hey, this one is 816 K, which is an outlier compared to the other records that are out there. So that's how the transformations and the recipe work. And once you have this recipe, you can just publish this, and so that you can go ahead and use that for future data sets, or basically you can run this with the whole data set that you have, because whatever changes that we did now, it is running on the sample, the 500 record sample. But with this recipe saved, you can go ahead and run a job with the whole data set or any other similar data sets. Hope this demo was helpful and you enjoyed it. Uh, Thank you.